This is lesson 2.8, addition and subtraction with mixed numbers in pre-algebra. Now back in 2.7 we did multiplication and division with mixed numbers, and in this section we're going to do addition and subtraction. And usually they do addition and subtraction first, but since the multiplication and division was easier, they did that first and they saved the more challenging stuff for this lesson. Now it isn't too bad, but it is going to take a little bit more work in order to figure these out. So let's look at example 1. We have 3 2/3, and we are adding 4 1/5. Now we have two opportunities, or two different methods, in order to solve this. First one is to change each one to improper fractions, so make that 11/3 and make that 21/5, and then go from there, find common denominators, add the numerators, and divide to get it back into a mixed number. And I'm not really going into detail on that because that's really not the quickest and easiest way to work, to make this work. So, but I do want to at least bring that up so you know that it is a possibility that you can do it that way. But the way that I prefer to do it, and it looks like the way the book seems to do it, is we put these on here vertically, 3 2/3 plus 4 1/5. And if I remember, most of earlier math books teach doing it this way as well. I don't know if they call it the stacking method, but I think I remember it being called that. So what we're going to do is we're going to find common denominators for both the 3 and the 5 here. We're going to leave the 3 and the 4 here alone, but we're going to find common denominators to 2/3 and 1/5. And I'm not going to go back and explain how to do that. You should have done it enough that you're already aware. But I multiply the 3 times 5 and the 2 times 5. And I want this to be a 15 as well, so I'll multiply those by 3. And that gives me 3 10/15. And this gives me 4 3/15. Okay, and then what I do is I just add these numbers up. So I'm going to add these fractions. And remember, you do the numerators only, and then you put it over the common denominator. And then I'm going to add 3 and 4 and get 7, and I'm done. So I wasn't finding or making improper fractions and then finding common denominators and then going back to an improper fraction to a mixed number. There's a couple steps there that we're not having to do when we do it this method. Okay, so let's look at example number 2 and get some more practice of doing this type of problem. So we've got 5 3/4, and we'll just stack it vertically right away. 9 5 6. Okay, so again, we're going to ignore the 5 and the 9 right now, and we're just going to look at the 3/4 and the 5/6. So the common denominator for 4 and 6 is 12. And again, I'll leave all that figuring on how to do that to you since you've already done a lot of it. And that gives me 5 9/12. And 9, I said it was 12, so 6 times 2 and 5 times 2. And then I add my 9 and 10 and get 19, and that's over 12. And my 5 and 9 is 14. Okay, so we're not completely done yet, because what happens here is the mixed number that we get for an answer has a fractional part that is an improper fraction. You can never have a mixed number where the fraction is improper. You can have a mixed number, in fact you have to have a mixed number that is proper, where the top number is smaller than the bottom number, but you can never have the top number larger than the smaller. All that means is that you're not done. Doesn't mean you did anything wrong, it just means we're not quite done yet. So we're going to change this 19 over 12 into a mixed number. So remember, to change from an improper to a mixed number, we divide. So we get 1 and 7/12. So instead of 19 over 12, we've got 1 and 7/12. And remember before, I think it was in the last section, I said a mixed number is a whole number plus a fraction. So we have our whole number plus 1 and 7/12. So what we do here, we take our 14 plus 1, and our 7/12 doesn't change. And that ends up being our answer. Now we have a proper fraction right there. The top number is smaller, and it's a mixed number like we started with, and we're good to go. So we'll do another one just to make sure you've got that. So this is example 3. So again, we're going to ignore the 5 and the 6, and we're just going to look at the 2/3 and the 8/9. We're looking for common denominators so we can add those. Alright, so in order to do that, we had to multiply, where our common denominator is 9, so we had to multiply the top and bottom by 3 in order to get 6 over 9. So 5 and 2/3 is the same as 6 over 9, or 5 and 6 over 9. And since we said the common denominator was 9, we don't have to do anything because that's already a 9. So 8/9. Alright, so we're going to add these together. So 6 plus 8 is 14, and that's over 9. And 5 plus 6 is 11. And again, this is improper. We don't like that, so we're going to have to change that to a proper fraction. And when you get numbers that are small like that, you really don't have to do the 14 divided by 9 like I do over here, because you can already tell that 9 goes into 14 one time with 5 left over. Okay, so you don't have to go through all the work of the division and all of that. You just say 9 goes into 14 once with 5 left over. We put it over the 9, and we're good to go. So then our answer is 11 plus 1 is 12, and we leave our fraction as is. And that's example 3.